In this lesson, we're going to look at all the different types of numbers. We have two key questions that we will be able to answer by the end of the lesson. Number one, what are the different types of numbers? And two, how are numbers classified? It's very important to classify numbers because when you do word problems or you're talking about real life situations, different applications, some numbers are not going to make sense. So we classify numbers to help us figure out when we solve a problem if it's going to work or not, or if that number is going to be reasonable. And we'll talk about more about that later. Let's look at the number types. The first type of number we're going to look at is natural numbers. These are also called counting numbers. These are the numbers you first learned when you were little and started counting on your own. So the number that we start with is 1, followed by 2, 3, 4, and so on forever and ever. So these numbers are positive. There are no fractions or decimals. There are no negatives. It's just the basic numbers we count with. Whole numbers are very similar. Whole numbers are natural numbers, but they also include the number 0. And then it's 1, 2, 3, 4, and so on forever and ever. So the only difference between whole numbers and natural numbers is that whole numbers include the number 0. Again, there are no fractions or decimals, and there are no negative numbers. When we start talking about integers, which is our third number type, that's where we include negative numbers. So integers basically are whole numbers and their opposites. So we include numbers such as -3, -2, -1, 0, 1, 2, 3, and so on. So these numbers go forever and ever, more and more negative, and then forever and ever in the positive direction. These numbers do include negatives, but they do not include fractions or decimals. The next set of numbers we're going to look at are called rational numbers. Rational numbers have the root ratio, and a lot of times ratios are written as fractions. So these are numbers that can be written as a fraction. So these numbers can be written as a fraction. They don't have to be written as a fraction originally. So if we look at some examples, the number 4 is rational because it can be written as 4 over 1. The number 5, 6 is rational because it's already a fraction. Those are easy. A number like 0.5 is a decimal, but it can be written as a fraction because 0.5 is the same as 1/2. Another example of a rational number that's a little bit more tricky is a number that repeats. 0.37, 37, 37, 37, forever and ever. If that decimal keeps repeating, it's going to be rational. If you can find a pattern, it's going to be rational. We'll talk in class about how to use your graphing calculator to come up with the fraction that represents that decimal. So rational numbers get a little bit more complicated, but you can use your graphing calculator if you need to help you out with determining if it's rational or not. Next, we have irrational numbers. Irrational numbers are numbers that cannot be written as a fraction. If you have a number that goes forever and ever, a decimal like 0.4718, 3132981, Where there's no pattern, it's going to be irrational. Up here, we had a decimal that had the 0.37 repeat. That made it rational. Down here, this goes forever and ever also, but there's no pattern, so it's irrational. The other numbers that are commonly irrational are square roots. Not all square roots, but most of them. And we'll talk about that in class tomorrow also. We can use our graphing calculator to calculate whether or not it's going to be a fraction or not. And we'll talk more about that tomorrow also. Lastly, we've got real numbers. Real numbers are all numbers that are on the number line. So if you think about a number line, the number line you know has 0 at the origin, has negative numbers to the left, positive numbers to the right of the origin. Okay, if you can find a number on the number line, it's real. All the numbers you know at this point in your math career are real. Okay, so if we pick negative 2.5, that's right here, so that's real. If I pick 1/3, that's right here, that's real. Every single number we know is a real number. I want to give you a visual to help you classify numbers into the types that they could be. So in this big box, I have all the numbers we know. Okay, those are all real numbers. Real numbers are split into two groups. One group is called rational, because they can be written as fractions. The other group is irrational, because they cannot be written as fractions. There's no number that fits into both. Either it can or cannot be written as a fraction. So irrational numbers are kind of on their own. Rational numbers can be divided into subgroups. So numbers that are rational could be positive and negative, so they could be integers. Integers can also be divided down into a subgroup because they can take out the negatives and just make it whole numbers. Then we can further break this down into one more subgroup, and that would be the natural numbers. Natural numbers are different from whole numbers because they do not include the number 0. So when you're trying to classify a number, you just have to figure out where it fits in this diagram. And we'll do some examples of that next. So we want to classify the following numbers. And again, they can fall into more than one category. So if we look at the number -9, -9, we first decide if it's rational or irrational. -9 can be written as a fraction if we put it over 1, which makes it rational. So we know it's somewhere over here. Okay, we know it's rational. Is it also an integer? Yeah, because it's negative and it's not a fraction or decimal. Is it whole? Nope, it's not whole because integers are the only numbers that include negative numbers. So if we go back and classify, -9 is obviously going to be real because all numbers we know are real. It's not irrational, but it's rational, and it's an integer. Let's look at the next example. We've got a number that does not have a pattern, but it goes on forever and ever. So when we look back at our diagram, we said rational was fractions, irrational could not be written as fractions. And if we look back at our notes, we talked about how rational numbers are the ones that don't have a pattern. Okay? So if we look at our number types, we've got a real number. So all the numbers we know are real, so it has to be real. Then we decide, is it irrational or rational? Because it does not have a pattern, it's going to be irrational. Once it's irrational, if we look at our diagram, we cannot break irrational down any further. There's nothing in this box to break down further. Okay, so once it's irrational, and that's it. Our third example, kind of similar, again has a decimal that goes forever and ever, but this one has a pattern. Okay, if you look, you have a 4, 5, 4, 5, 4, 5 that goes forever and ever. So this decimal has a pattern. So if we had to classify it, again we start with real. And then we have to decide, is this irrational or rational? Well, we said if it's a decimal that goes forever and ever but has a pattern, it's going to be rational. The next question is, can we break it down further and say it's an integer? Well, integers do not include fractions or decimals, so it would not be considered an integer. The furthest we can classify it would be a rational number. The last set of examples we're going to look at are true and false problems. We have to decide if each statement is true or false. So if we are looking at the number 6, and we have to decide if it's an integer or not. Integers are whole numbers, and they're opposites. So if we look at our diagram, the number 6 is rational because it can be written as a fraction. And it's also an integer because it does not include fractions or decimals. So when I look at this, is 6 an integer? Yes, it is. So that is true. -2 is a whole number. We have to decide if that's true or false. If we go to our diagram, -2, again, is on the rational side, because we can make it into a fraction. It's an integer because it's not a fraction or decimal. But whole numbers cannot include negatives. So if we look at this, -2 is a whole number, we would have to say that is false. Negative numbers cannot be whole numbers. Lastly, 1/2 is a rational number. Well, we know 1/2 is real. So when we're determining rational or irrational, we just have to decide if it can or cannot be written as a fraction. Remember, rational means ratio or fraction. So is this a fraction? Is it a rational number? Yes, it is. So this would be true. That is all we're going to talk about in this lesson regarding number types, and we will continue to review them as we work on problems that require us to look at the reasonableness of our answer. And I hope you enjoyed the lesson. Thank you.